Greetings to all the viewers. Now the topic we are going to discuss about is terpenoids. Terpenoids are natural products. These terpenoids are the polyisoprene units where you can find isoprene units in natural rubber. In the similar manner, terpenoids also composed by isoprene units where you can find 2-methyl 1,3 butadiene, which is repeated in the manner where head to tail arrangement will be there. So these terpenes are the products which find potential applications to the mankind. So let's go with these terpenoids. These are the part of natural products and these are considered as a core scaffolds, and we are going to evaluate these components and they are working like a potential leads as well. So let's dive into the topic called terpenoids. Let's define terpenoids first. Terpenoids, also known as isoprenoids, large class of organic compounds derived from 5-carbon isoprene unit. Isoprene is the unit. These can be repeated a number of times so that terpenes will be generated. Okay, just like the natural rubber where we can find isoprene units in that. In the similar manner, terpenes also made up of these isoprene units. So these isoprene units are called 2-methyl 1,3 butadiene, which are repeated in the manner so that we will go for the polymeric chain, right? They are characterized by their distinct structures and are found in many plants, contributing their aroma and flavor. So these are the terpenoid compounds. Terpenoid compounds are available in many plants. If you go with these mango, pepper, and these are called berries, and here camphor. All these components are composed by these terpenoid compounds, right? So they are having aroma smell. Aroma means what? A pleasant smell will be there, and the flavor is also. So they are imparting flavor to the kind of material or natural product what we are having. Terpenoids play important role in ecological interactions, including plant defense, right? So terpenes are the essential components of plant defense. They're also significant in the pharmaceutical, fragrances, and food additives, right? So here in the pharmaceuticals, we can find applications of terpenoid being it is the medicinal core component and fragrance. So they used to give the fragrant smell, aroma smell, so that in here also we can go with, and food additives. So being the components are flavoring agents so that food additives we can use them. So this is the entire sphere of terpenoids. All the terpenoids are categorized in such a manner. You can go with the pepper. Pepper is a kind of spice. So this pepper is also composed by this terpenoid moiety. That means polyisoprene units are present in that. And another is about lemon. Lemon is the kind of citrus fruit. And here citrol is the kind of terpenoid we can find in this lemon. And next is about myrcene. Myrcene is the part of this. Myrcene is present in this mango. So that here also myrcene also kind of terpenoid you can locate in mango, right? So the entire session what we are covering is powered with AI. The material, whatever content we retrieved, so that is taken from AI powered session it will be. And next is about pine. So here pine trees will be there, no? So these kind of pine trees are used to give the berries. These berries are also constituted with this kind of terpenoids. And another is about lavender. So here linalool will be there. They are existing in lavender color, and linalool is also the part of this terpenoid. Here carene will be there. So this carene is also the part of this terpenoid. It is also essential component over there. And next is about nerol. So here nerol, which extracted from this rose, and from the grapes also we can extract these nerol and geraniol. Both are said to be what? Isomeric components. So from the grapes we can extract geraniol. From the rose you can extract nerol. This is the way terpenes are present, and a few examples are provided in this chart. Let's classify. So here being it is a kind of AI powered session, so that content retrieved from this AI platform. And terpenoids can be classified based on the structure and the number of isoprene units, right? Classification purely based on isoprene units which are used to bind these components, so that we will make terpenoids. Monoterpenoids we will go with, composed of two isoprene units. When two isoprene units are going to join, so that we can say that is the monoterpenoid. So here already we know that isoprene is the compound where you can find four carbons and one side chain will be there. Total five carbons chain length. When two isoprene units are joining, so that we can say C10 composition will be there. So that it is a dimer and a monoterpenoid we can regard it as. Examples include limonene and menthol. Limonene, menthol are this example for this monoterpenoid. And second is about sesquiterpenoid. Sesquiterpenoid, how many units we can notice? Three isoprene units if present, that is denoted as a sesquiterpene. And here three isoprene, each isoprene five carbons, so that 3 multiplied with 5, so that C15. So 15 carbon atoms are present over. And examples for sesquiterpenoid is farnesene and bisabolol, right? So farnesene and bisabolol are the classical example for sesquiterpenoid. And next is called a diterpenoid. Diterpenoid is composed by four isoprene units. Each isoprene is 5 carbon, so that four isoprene we can go with C20. Examples are taxol and retinoic acid, right? So this is the way diterpene is given. And a triterpene, how many units? Monoterpene 2 units, triterpene obviously 6 units will be there, where you can notice C30. So for this C30, examples are squalene and cholesterol. This is the kind of session what we are discussing for competitive examinations or else any academic examination. This is important. So many times such kind of examples will be given under for example, if we are asking about a triterpenoid will be there. For this triterpenoid, what example you can notice? So in that manner, we have to trace out what is the particular answer regarding this terpenoid compounds. So that examples are most vital in classifying these terpenoid compounds. Triterpene, if you are taking 6 isoprene units will be there, and then that squalene and cholesterol are the examples. Tetraterpene, if we go with, tetra means how many? So here mono means 2, then tetra means 8 isoprene units will be there. If 8 isoprene units are located, we can say it is the C40. 8 can be multiplied with a 5 carbon chain of isoprene, so that 8 5 is a 40. So that C40 is the composition of this tetraterpene. A well-known example is carotenoids such as beta carotene. So beta carotene, these carotenoids, beta carotene mainly constituted with vitamin A, and these are present in where beta carotene is located in what vitamin A is present in this one, and carrots are the best examples over there. Polyterpenoids composed of many isoprene units. Rubber is a notable example. So that's what we are saying. Isoprene is the main composition of isoprene is the main composition of this rubber, right? So that we can say, so here rubber is a polyisoprene. So polyterpenoid, obviously it will be, right? So rubber is the notable example. This is the way classification is provided. Mono, sesqui, di, tri, tetra, polyterpenoid will be there. Each class exhibits unique properties and functions in nature, right? So everywhere, for every classification, for every classified fragment, we can notice the properties and functions of these compounds. Few examples are mentioned with their chemical composition. So here you can notice beta-myrcene and D-limonene will be there, and another alpha terpenine will be there, alpha pinene will be there, cetrol will be there, citronellol will be there, camphor will be there. This is the way the compounds what we are noticing. Everything are composed by the chemical composition where all isoprene units got joined. Either open chain molecule will be there or else a ring type of structure. Ring type of structure also we can notice. The isoprene rule. Now we are going to discuss about the main topic of this terpenoids. So in order to construct these terpenoids, isoprene rule is most important. Isoprene rule stands for there is a certain kind of guidelines we can go with in order to join isoprene units to get terpene compounds. The isoprene rule is also known as uh, isoprene law states that natural terpenoids are derived from isoprene units. So isoprene fundamental compound where we can notice C5He8 will be there. And they can be constructed by joining together multiple isoprene units. When multiple isoprene units are going to be joined so that here a ring extension, chain extension will be possible. This leads to the following key points. Structure of the compound. Terpenoids are built from the isoprene. Isoprene is IUPAC name is mentioned over here. 2-methyl 1,3-butadiene will be there, and which can be combined to form larger molecules, right? Whenever this isoprene unit 2-methyl 1,3-butadiene is there, larger molecule will be formed whenever we are joining in such a manner. And neither is about polymerization. Isoprene units can link together in various combinations, resulting in the compounds with different carbon chain lengths. So whenever polymerization is possible, so that may gives rise to the longer chain length sometimes, a moderate and a minimum medium chain length also possible. This is why polymerization is carried. And in either the important thing, head to tail manner. Head to tail in the sense whenever we are taking isoprene unit, isoprene is the kind of 1,3-butadiene, 2-methyl 1,3-butadiene. So that used to join with any other isoprene unit with 1-to-1 addition or else 1-to-4 addition. That is known as head to tail or tail to head, both. So either of the side we can go with the linkage of the compound so that head to tail or tail to head kind of combinations are possible in order to construct these terpenoid compounds. A number of units used to give rise to the most number of terpenoids based on the number of isoprenes, the way they are going to join, so that different kind of terpenoids we can notice over. The isoprene rule helps to explain the structural variety and complexity in the natural terpenoids, right? So natural terpenoids, if we go with different kind of their chemical composition will be there, and complexity is also noticed over. So this is the way isoprene rule can be categorized. And here we can see compound, it is the part of carotenoid. So here a cyclic ring will be there, and here is the double bond we can notice, and all the double bonds are existing in the conjugation. On this carbon atom, gem dimethyl are present, and here another side chain called methyl group is there, and here is the double bond. We can notice another methyl side branch is there, and here also another methyl side branch is located. So this is the entire structure of carotenes. Carotenes are located, and even vitamin A is also composed with the same kind of chemical composition, right? So if we observe this entire skeletal of terpenoid, so here 1, 2, 3, 4, 4 carbons are there. These 4 carbons are laying on the same chain, and one of the carbon is the side chain. So if you observe like this is known as 2-methyl 1,3-butadiene. That is the core component. This is called isoprene. This moiety is denoted as a isoprene, where first carbon is ending with this 4th carbon atom, and this 4th carbon is going to join with another first carbon of isoprene. This is the way 4th carbon is regarded as a tail, first carbon is denoted as the head. So this is the way, head to tail or else a tail to head, both the vice versa, both the combinations are possible in order to construct these isoprints, in order to construct this polyisoprene. So that 1, 2, 3, 4, another isoprene we can notice over. So this is a kind of one isoprene, and this is another isoprene unit we can locate, and this is third isoprene unit, this is the fourth isoprene unit. So this carotenoid is composed by 4 isoprene units. If 4 isoprene units are present, we can mention it as a biterpenoid. So 4 isoprene units if present in the given compound, organic compound, we can say it is the biterpenoid. And moreover, we can notice one ring structure. So monocyclic, um, what it is? Diterpenoid it will be. The basic carbon skeleton of monoterpenoid is follows according to the isoprene rule. Isoprene rule stands for what? Head means the first carbon, tail means the fourth carbon, right? So here head is started, and on the second carbon, another carbon will be there. This is a side branch, third carbon and fourth carbon. Fourth carbon is denoted as a tail. So this tail is going to join with another head. So this is designated as a tail to head or else a head to tail, whatever pronunciation we can go with. So this is a kind of a combination we can notice for this isoprene. Special isoprene rule is also present, but generally we will go with head to tail and tail to head kind of arrangement. This is called isoprene rule. So by that isoprene rule and it's a related examples we observed. Now we will go with the individual components, what is called pepper. Pepper, scientifically designated as a Piper nigrum. This is a scientific name of pepper, and it is widely used as a spice. Pepper is the common spice used in a food additive, known for its pungent flavor and aroma. So it is the kind of a spice used in the food additive. It is often referred as the king of spices, right? King of spices, and it contains the historical significance. Key characteristics: origin, where pepper is located, native of South India, and black pepper is cultivated in the tropical regions worldwide. So here worldwide, pepper is there. In most of the countries, pepper is used instead of chili also, right? So this is the way origin of pepper we can notice, and the flavor. So everybody aware about these pepper, these seeds, and it is a sharp and spicy taste we can notice. And the terpenoid which extracted from this pepper will be piperin. Piperin is the kind of terpenoid which is present, which is the reason for this sharp and spicy taste, a key chemical compound for this. And forms. So here pepper may available in peppercorns, brown pepper, and the blends with other spices also. So these are the kind of another transformations for these pepper. So here, in what way pepper can be utilized? What applications we can notice? Culinary, used to enhance the flavor of wide variety of dishes. Whenever pepper added, so pepper added, what happens? Taste that what kind, the taste of that food will be enriched, so that it used to increase the taste of that food from savory to sweet. So in all kinds, that might be a kind of a spicy dish or else a sweet. Wherever we can use this pepper as a additive, food additive, right? Another value is a medicinal value. Traditionally believed that so many health benefits we can extract from this pepper, where piperidin is the terpenoid we can extract from this, and it included with the digestion. Pepper used to digest the food in a short time, and possessing antioxidant properties. So it used to retard the oxidation process. So that antioxidant property is also present in this pepper, piperidin terpenoid. Then aromatherapy. Aromatherapy in the sense sometimes used in essential oil stimulating properties, right? So from this we can extract the oil also. That oil extracted used to relieve the pains and used in the therapy. So that used in the curation process. This is the way what pepper can be used. So where we can notice this pepper and what kind of flavor we can exist and what is the reason for that flavor, in how many forms it is available, and in what way we can go for its applications. Now we will see about how many forms pepper is available. White pepper will be there. It is made from ripened berries. So here berries are used to extract this white pepper, soaked to remove outer skin, resulting in the milder flavor, right? So whenever it's soaked into the water, and the entire outer layer will be removed, and we will extract this white pepper. Next is about black pepper, harvested when berries are still green and then dried. Ripened, from the ripened berries we can extract the white peppers. So if not not properly dried, but they are still in that condition only, so from that we are able to harvest black peppers. Green peppers also present, unripened, often preserved in the brine and vinegar. So here green pepper is extracted. uh, how can we extract? Without removing the outer skin. Whenever green pepper, directly berries are taken and they preserved in the vinegar or brine, so that what happens, green pepper can be used. This is black pepper is not only culinary, and all these kind of peppers are found applications in food additives. And here we can notice piperin chemical composition. Here, this is piperidine ring will be there. It is the chemical class of piperidine ring, and we can see here benzene, and another heterocyclic ring is also there, and a conjugated system. We can notice the entire structure corresponds to the piperin, and its chemical composition will be C17H19NO3. This is the way pepper will be given. Next, let's go with another compound called citral. So citral is a terpenoid extracted from the lemon, and it is naturally occurring compound and classified monoterpenoid. Citral is the kind of monoterpenoid, important compound of essential oil. In the essential oil synthesis, citral can be extracted, and strong lemon scent. So even in the perfumes also we can use this, and its chemical composition is provided. C10H16O is the chemical composition of citral, and the citral consists of two isoprene units. When two isoprene units are joined, so that we can say monoterpene it will be. Isomers. Citral have two isomers, geraniol and nerol. Just we saw in the initial classification, geraniol and nerol will be there. So these two isomers are the part of are present in the citral. Uses. Fragrance will be there. Everybody where citrus fruits are having that kind of one distinctive fragrance or flavor, commonly used in the perfumes and refreshing. Citrus aroma used for the refreshing perfume. Food industry. Even in the food industry, we can utilize it is a kind of flavoring agent. So we will use lemon in the food additive, so that in food industry also we can utilize. Pharmaceuticals. Potential therapeutic products will be there included, antimicrobial and anti-inflammatory used to. So whenever we are consuming lemon juice every day, what happens, it used to avoid the infectious pathogens. Antimicrobial agent it will be. Inflammation, so that means any kind of swellings and pain induced swellings are present, they are also mitigated or minimized. Anti-inflammatory agent as well. This is the way pharmaceutical applications we can notice for this citral. Citral is valued not only for its aromatic properties, but also for its versatility in industries as well. Or not only as a food additive, even in the industry we can utilize them. And we will go with another compound called myrcene. Myrcene is the monoterpene. Myrcene we can notice as a monoterpene, one of the most common terpene. It will be available in various plants, particularly in the hops, bay laurel, and lemongrass. Even in the lemongrass, this myrcene is located. Mango, we can extract this myrcene. Key characteristic, chemical formula for this one will be C10H16. Myrcene has a branched chain structure. It is the kind of branched chain. Chain is there, and another side chain will be there. So that branched chain structure will be there. And we also locate a double bond over there, making it a colorless liquid at the room temperature. So it is a kind of colorless liquid. and aroma. So distinctive flavor you can notice whenever mangoes or else any lemongrass is there or else bay laurel is present. We can experience a distinctive aroma smell from that one. So that aroma smell will be provided by these kind of terpenoids, and they are earthy, musky scent with the hints of cloves and herbs. Whenever you can observe the cloves, so just like cloves and just like herbs, here also we can find the aroma smell. Next, about uses, right? Used as a flavoring agent in the food and beverages, right? So they used to impart and increase the what a flavor of food and even beverages. Okay, storage, food also we can use them. So just like a pickle or else just like any kind of material we are preserving. So there also these kind of myrcene are uh, this kind of material can be used. Next is about fragrance. Fragrance being they are aroma in nature, they are extracting, they are exhibiting aroma smell. So that fragrance is obvious condition for that. So that perfumes will be synthesized and cosmetics will be there. Aromatic qualities are present over. Medicinal research suggests potential anti-inflammatory, analgesic, and sedative agent it will be. Inflammations, any pains included with the swelling can be mitigated. Analgesic agent, pain relieving agent, it will be sedative, used to induce the sleeping tendency, right? Myrcene is also believed to enhance the absorption of other cannabinoids and cannabis, right? So absorption, in the absorption process of these chemical components also we can utilize this myrcene, that is the terpenoid. Importance in the cannabis. Okay, so this is the chemical composition of the myrcene. We can notice side chain methyl will be there. 1, 2, 3, 4 carbon chain length with 1 methyl, 1, 2, 3, 4 carbon chain length with 1 methyl, and we can say it is the monoterpene with open chain it will be. Myrcene is notable in the cannabis community for its potential to contribute to the encourage effect, where various compounds work synergically to enhance overall effect. Overall, myrcene is valued for both its aromatic properties and potential therapeutic benefits. So aromatic properties will be there, and therapeutic, even in the curation process, disease curation process and medicinal applications process, we can go with these terpenoids called myrcene. Let's go with another terpenoid called pinene. Pinene is a bicyclic monoterpene and is the most widely used in nature. It is commonly found in the essential oils of various coniferous trees. Pine trees, everybody aware about pine trees. Here is the what picture which is representing this pine tree, from which pinene alkaloid is extracted over. Essential oils will be extracted from this pinene and coniferous trees. So pine trees are the part of coniferous. Coniferous are nothing but mountainous region which are able to grow at the mountainous region are called coniferous, such as pine as well as some other herbs also present over, right? And if you see the key characteristic chemical formula is mentioned as C10H16. Isomers, two isomers are available, alpha pinene and beta pinene. So these two are said to be isomers of the pinene. Alpha pinene known for its pine-like aroma smell. So aroma smell is present, and it is the most commonly available isomer for this pinene terpene. Beta pinene will be there, slightly different structure and more herbal, woody scent will be there. So a woody perfume it will be. So this is beta pinene. Then both are composed by the aroma smell. Obviously, isomers have the fresh piney fragrance will be there, and often associated with the scent of pine forest. So whenever we are in the closure region to these pine trees, whatever fragrance we are getting, even by extracting the oil from this one pine trees, that piney fragrance also we will experience, right? Further, we are going with their applications. sometimes used as a flavoring agent in the food. Obviously, because of its aroma and a kind of a fragrance, it used in the food additive. So food products. So as a flavoring agent, we can add fragrance. Commonly used in perfume. Obviously, fragrant agent used in the perfumes and cleaning products in order to clean. There also we can apply fresheners, room fresheners also. This pinene can be used, and it's a refreshing scent. A refreshing scent, in that also this pinene can be used, medicinal value. Research suggests that potential anti-inflammatory, bronchodilatory, and antimicrobial properties. So here, anti-inflammatory swelling and painful swelling, if present, that will be mitigated. Bronchodilatory, in the sense it is related with the pulmonary disorder. Pulmonary disorder means breathing related problems if present. In that condition also we can apply this pinene. Antimicrobial, used to mitigate the pathogens. Disease causing organisms are called pathogens. In that case, that may be a bacteria, virus, algae, fungi. So in that case also we can go with the curation with this pinene. Importance in cannabis. Pinene is also notable in the cannabis industry for its potential therapeutic effect and the role in the encourage the effect of cannabinoids and terpenes. So here therapeutic value is the most important one. That means what? Pharmaceutical. In the pharma industry, we can apply this pine oil or pinene terpene. Overall, pinene is valued for its aromatic properties and potential health benefits. Aromatic properties will be there. Aromatic properties, in the sense some distinctive properties are allocated for the aromatic compounds they are used to exhibit. In addition, potential health benefits also. So whenever we are consuming this pine oil, or else as a food additive or as a flavoring agent, so that health benefits also improved, right? So here we can notice alpha pinene and beta pinene. What is the difference between these two? Alpha pinene is indicated with the double bond inside the ring. In beta pinene, the double bond is shifted to the outside the ring. So both are having exactly resembling structures except double bond location. Double bond if present in inside the ring, that is called alpha. If exocyclic ring is there, that is called beta pinene. Now we will discuss about another compound called linalool. Linalool is a naturally occurring terpene. Linalool is a naturally occurring terpene, and which is present in lavender flowers. Here we can notice the lavender flowers, and from this we can extract linalool, which is the terpenoid compound. Right? Key characteristics. Chemical formula is denoted with C10H18O. C10H18O is the chemical composition of this linalool structure. Linalool is a chiral compound. So chiral in the sense what? Wherever carbon which is surrounded with the four different functional groups around and optically active in polarimeter is said to be a chiral compound. So this is the compound. Linalool is the chiral in nature. And two, enantiomeric. Obviously, when chirality is present, either it might be enantiomeric or else diastereomeric in nature. So here it is the kind of enantiomeric isomer. So S-linalool will be there. So enantiomers are said to be what? S R configuration will be there. S configuration will be there. S-linalool existed and R-linalool also existed. Okay, so both are available, which are present in the linalool, and different scents and properties are available for them. Aroma. So obviously terpenes, turpentine oil. Everybody aware about turpentine oil. Everybody aware about pine oil. So all the kind of terpenes are located with this aroma smell. This is a common property. So here also linalool is the kind of compound where sweet floral fragrance will be there, and it is the reminiscent of lavender, making it popular in the perfume and aromatherapy. So in the oil massage therapy we can utilize, in the perfume industry also we can utilize this linalool. Okay, now we will go with its applications. Fragrance, right? So being aroma smell is located, it is exhibiting fragrance and used in perfumes. even cosmetics, household products. In that also we can apply this lavender linalool, right? Culinary, found in various herbs and spices, coriander and basil in contributing to their flavor profiles. So whatever coriander we are using, coriander leaves, everybody, that is the most common curry leaves we can use in our kitchen platform, that used to give, that used to enhance the flavor of that whatever we are cooking. So it used to enhance the flavor. Linalool is the component which is present in that kind of what coriander. And neither is about medicinal. Research suggests that potential anti-anxiety, anti-inflammatory, analgesic, making it a subject of interest therapeutic applications here. So medicinal applications also available over there. Anti-anxiety, anxiety will be mitigated. Anti-inflammatory, pains can be relieved. Analgesic, again, it is a pain relieving and subject to the interest therapeutic application. These are the curative properties available for this linalool. Here is the chemical composition we can notice. If you observe, it is the kind of open chain molecule where CH2 is accompanied by the double bond, and here is the carbon with the methyl and OH on the same carbon atom. And we can notice two methyl are joining over there, and here another double bond is there. So here two double bond, they are not in the conjugation, and this is the compound where open chain molecule will be there. If you observe, two terpene units are joined, two isoprene units are joined, so that we can say it is the monoterpene. Acyclic monoterpene it will be, acyclic monoterpene. Linalool is also found in many cannabis strains and considered to be enhanced overall effect of cannabinoids, contributing to the encouraging effect. Right? Overall, linalool is appreciated for its aromatic qualities and potential health benefits. So here aromatic properties will be there. Aroma, smell, it used to impart, and in addition, health benefits also given by this lavender linalool. Next, let's go with the carine, right? Carine is the kind of delta 3 carine and D3 carine, both are available over there. It is a kind of bicyclic monoterpene. Bicyclic monoterpene indicates what? Two ring structures will be there and two isoprene units will be there. Two ring structures denotes bicyclic. Monoterpene is nothing but two isoprene units when joined, that is monoterpene. A naturally occurring hydrocarbon. It's a chemical formula will be C10H16. Carine formula will be C10H16. It is a kind of monoterpene. It is found in the various essential oils, particularly in the pine and cedar oil. Here is some key points about the carine. Some points are mentioned over. It's a structure composed by two fused rings. Being it is a bicyclic, we can say two ring structures will be there. Cyclohexene. Cyclohexene means what? Six-membered ring with one double bond is called cyclohexene. And cyclopropane, three-membered ring with without any double bond, that is called cyclopropane. One is six-membered, another three-membered ring is located in that. Two ring structures in that, one is six-membered, another is three-membered ring. Making this bicyclic structure stereochemistry. So here how the orientation of all these compound, all these carbon atoms and the side chains, the entire or what orientation of this arrangement, skeletal structure is called its stereochemistry. How the arrangement of the functional groups and side branches are present on the core skeletal structure is called its stereochemistry. Carines exist as a two enantiomeric forms, +3 carine and -3 carine. Plus denotes what? Dextrorotatory. Minus denotes a levorotatory compound. Place form is being more common in nature. Among two enantiomeric forms of two carines, one is more common in nature, that is +3 carine is the commonly available and most abundantly available. Natural sources where we can find, from where we can extract this carine compound. It is commonly found in turpentine oil. So carine present in turpentine oil, which comes from the pine resin. Again, it is extracted from the pine trees only. right? So turpentine oil, pine tree oil, linalool oil, most of the things are extracted from coniferous plants only, pine trees only, so that it is the turpentine carine is extracted from this turpentine material, and the oils other coniferous like spruce and fir. Fir tree is also located in the mountainous regions only, so that all these are the sources in order to extract this carine. It's also present in citrus oil and rosemary. So citrus oil, from the citrus oils also we can extract the carines, and rosemary, the rosemary oil also composed with a carine compound. This is the way natural source for carine is provided over and order. So obviously all the terpenes are aroma in nature. So these are called essential oils as well. Another alternative name for the terpenes are essential oils, right? So odor. Carine has a pleasant, sweet, pungent odor and used in perfumes, cosmetics, and flavoring due to its characteristic, right? So here very pleasant in nature, and a very sweet taste and pungent odor will be there, and because of this reason we are using in the perfume and cosmetics, right, where we can apply these carines. In addition to its fragrance, it also used in organic chemistry for synthesizing other compounds also. So it is a kind of raw material in order to synthesize a bulk materials. So it is a synthon in the organic chemistry. It has applications in the production of resins, intermediate in the pharmaceutical chemistry. So it also a kind of intermediate in the pharmaceutical chemistry. In the pharmaceutical chemistry also, this is the material from which so many final products will be transformed. The chemical reaction carine, especially 3 delta 3 carine, exhibits several interesting properties due to its bicyclic structure. Bicyclic structure, just now we got that 6-membered ring, another 3-membered ring will be there. So here bicyclic structure will be there, because of this kind of arrangement only its properties will be imparted. Here are some details about the reactivity and applications of this one. Electrophilic addition. So being double bond is present, it is not in the aromatic chain, so that it is obviously go with the electrophilic substitution reaction and susceptible for electrophilic addition reaction. For example, you can add water. Water will be added at the double bond called hydration, and acid catalyzed hydration will be carried over, so that we will go with the OH and OH. Hydroxy groups will be generated, vicinal. Halogenation. So moreover, double bond easily fragmented by the addition of chlorine or bromine, whatever the kind it might be, so that halogenation also possible, bromine, chlorine forming halogenated products. Oxidation. Chlorine can be oxidized using potassium permanganate. When potassium permanganate is added, what happens here? OH here, OH, bears oxidation will be carried. Ozonolysis. Ozonolysis means what? We are supposed to cleave the bond over there, so that adjacent two terminal carbons will be converted into a kind of aldehydes or ketones. So that is the way ozonolysis is carried. Double bond completely fragmented, and this carbon will be turned into a double bond O. This carbon also turned into a double bond O. This is useful for generating functionalized derivatives. So, so many kind of new compounds will be extracted from this compound that is called carine. By that we concluded for carine, and let's go with nerol. Nerol, just to be discussed at that time. So nerol, geraniol, both are said to be what? Isomeric in nature. They are naturally occurring monoterpene. Monoterpene means 2 isoprene units when joined, called monoterpene. Molecular formula is designated as C10H18O. C10H18O is the molecular formula for this nerol. It is an isomer of geraniol. Nerol, geraniol both are isomeric in nature, and they differ mainly in the geometry. So here geometry means what? The orientation of the functional group will be differ around the double bond. Double bond orientation if changed, geometrical isomerism will be possible. Here is an overview for the nerol. Overview for the nerol is given. Molecular structure. Nerol is the kind of cis isomer. Cis isomer means what Z configuration will be located over, and here around the double bond, two similar groups are located on the same side, which is called a cis. And it distinguished from the isomer geraniol. Geraniol is the trans isomer. So where we can notice it as a E isomer as well. The structure constitutes a 10 carbon chain. So here nerol is a 10 carbon chain, being it is a monoterpene, so the two isoprene units got joined, and IUPAC name is provided over Z3,7 dimethyl octa 2,6 diene 1 ol. This is the IUPAC name for this nerol order. How can we get the smell order for this one? It is very fresh, sweet, floral, fragrance, reminiscent of roses, which makes it a popular ingredient in the fragrance and cosmetic industry. In the fragrance means perfumes we can use, and cosmetic industry also we can go with this nerol. And physical properties, colorless in nature, oily liquid. All terpenes are called essential oils, so that it is a kind of oily liquid. It will be low solubility in the water. Oils obviously water insoluble, so that low solubility you can notice, but good solubility in the organic solvents. If we add organic solvent like ethanol, so that it will be soluble. This is the way nerol. Nerol easily go with oxidation. Here is the chemical composition we can see, where two double bonds are present and one side methyl group is there, and two isoprene units are joined. It is the a cyclic system. No ring structure will be there, and we can go with the oxidation of this one. Whenever oxidation is possible, corresponding aldehyde or carboxylic acid under the certain conditions will be generated. Here hydroxy will be there. It finally converted into COOH. That means carboxylic acid will be generated. Esterification. So being it is a hydroxy compound, whenever another acid will be added, so it will go with the esterification. Nerol undergo esterification to form the esters, often used in the fragrance of the flavors. Okay, so this is hydroxy. When another compound of carboxylic acid is added, so that ester will be generated. Nerol acetate we will get. Nerol acetate will be generated by treating with acetic acid. The compound used in the perfumes and cosmetics. Perfumes and cosmetics manufactured with this nerol acetate. Hydrogenation. Whenever hydrogen is added, what happens? Double bond gets saturated. Here is the one double bond, here another double bond, so that will be converted into a saturated one. When subjected to the hydrogenation, the double bond of nerol can be reduced, forming saturated alcohol derived from the nerolol. Whenever these double bonds are diminished, they are removed. What happens? Nerolol is the name for this saturated compound. Isomerization. Nerol can be isomerized in a trans isomer geraniol under acidic conditions or application of the heat, right? So here geraniol to nerol, nerol to geraniol, that isomer transformation is possible, conversion is possible by applying heat. By heating, one of the isomer can be shifted. Nerol can be converted into geraniol. Applications. Fragrance and the flavor industry. Being it is the aroma in nature, so that perfumes we can manufacture. Flavor. Food additive, it will be whenever it is added, so it will enhance the food flavor. Due to its pleasant floral scent, nerol is widely used in the production of perfumes, body care products, and soaps. Flavoring to provide the fresh, floral note and beverages, particularly citrus flavored fruits. Okay, so nerol, geraniol, so these are extracted from berries, right? So that it is the kind of citrus related fruits. From that we can extract them. Cosmetics. Nerol is the common ingredient in skin care and cosmetic products for its fragrance and sometimes for its reported soothing and antimicrobial properties. Right, antimicrobial property will be there, and cosmetic industry we can utilize. Fragrance will be there. These many applications we can notice for nerol. Chemical intermediate. Organic synthesis nerol can be used as a precursor to valuable chemicals such as isomer geraniol, right? So so many kind of compounds will be synthesized starting from this nerol and geraniol, cetrol and other terpenes used in the fragrance and pharmaceuticals. So many fragrant materials and pharmaceuticals can be manufactured starting from this, what we can say, nerol. Biological and medicinal properties: antimicrobial in nature, antioxidant in nature, calming effect. Antimicrobial means what? Antifungal property will be there, antibacterial, antiviral property will be there. Antioxidant property potentially contribute health benefits used in natural therapies, skincare products. There we can apply these nerol. Calming effect. Due to its scent smell, nerol sometimes used in aromatherapy and relaxation and stress relieving agent it will be, right? Another compound is called geraniol. Geraniol is the isomer of nerol. Its chemical composition is provided over C10, He18O is the chemical composition of geraniol, differing in the configuration of the double bond, which makes geraniol the trans isomer. E isomer it will be. Nerol is the cis isomer. Nerol cis and both are isomeric in nature, right? Structure and properties. Molecular structure. So here 10 carbon, C10He18O will be there, no? So that you can notice hydroxy group over there, and terminal position double bond between the second and third carbons, as well as between the sixth and seventh carbon. Two double bonds are located over there, and double bonds are existing in a E configuration. IUPAC name: 3,7 dimethyl octa 2,6 diene-1-ol is the IUPAC nomenclature for the given compound geraniol. Order. How can we get the smell for that one? Geraniol is the sweet in nature, floral in nature, and roses, similar to roses. How roses are giving perfume, that means fragrance, in the same manner here geraniol also giving, which makes it a common ingredient in a perfumes and scents. Physical properties: it is a pale yellow in color, so here you can notice the oil, and being it is oil, water insoluble in nature, soluble in the organic solvents like ethanol and diethyl ether. Natural occurrence: geraniol is found in the essential oils. Essential oils, geraniol is found, and rose oil, palmarosa oil, citronella oil, and lemongrass oil, perennials, lemons, and other citrus fruits. From all these, we can extract this geraniol, right? Rose oil we can extract, palmarosa oil we can extract, citronella oil we can extract, lemongrass oil. From all these, this geraniol compound will be extracted. Here we can clearly notice geraniol. So if you observe geraniol and nerol, here is the comparison provided. Here geraniol is given with the CH2 group is indicated, just like how the methyl is inclined, in the same manner the CH2OH will be there. But in case of this one, this methyl and this CH2OH are inclined in the opposite direction. So this first carbon orientation is changed so that both are isomeric. Nerol and geraniol both are isomeric in nature. And this is the way we can go with the comparison of chemical structure. Then reactivity, oxidation. So if you oxidize, two double bonds will be reduced by the addition of hydrogen, and geraniol component of citral further to geranic acid, right? So sorry, if we go with the oxidation process, whatever CH2OH is there, this CH2OH is converted into COOH. That is, hydroxy compound will be converted into the carboxylic acid, right? Hydrogenations. In this hydrogenation, double bond will be added with hydrogen, so that the compound hydrogenated product is called citronellol. Citronellol is the product which is extracted by reducing this double bond and this double bond. So this is another fragrant smell containing compound by the hydrogenation, whatever we are getting. Another process called esterification, being again it is a kind of hydroxy added with the carboxylic acid, so that we will go with the removal of water and give ester. That ester is a geraniol. So here another flavoring compound will be generated, the ester whatever we are getting. Isomerization, when the geraniol is added with acid and further heated, so that it will be converted into a nerol. nerol compound will be generated. So here both are interconvertible isomers, interconvertible isomers. Diels-Alder reaction, right? So if we see this, being it is a kind of double bonded system, so that a diene system will be there. So it will participate in a Diels-Alder reaction. Diels-Alder reactions are most important in a organic synthesis. By this, we are going to conclude a few terpene compounds are mentioned over. Hopefully, the session is very informative and it is helpful for your preparation, either for post-graduation, graduation, or else in the level of intermediate. Uh, Anywhere, this kind of what natural products terpenoids are most important. Thank you for giving me the opportunity. Thank you.